There we go, and I'm live. I'm going live a couple minutes early. That's okay. For those of you that are watching, obviously you are on some kind of electronic device where you're watching. I suggested to everyone that they get out their Chromebooks because I want to do a Chromebook activity first and foremost to kind of start off this class period. I'm going to remind you of a few things before we get going with that. Then I will talk about said homework that was due for you this morning. Then I want to talk about what I have planned for you for this upcoming Monday. Now, the first thing I want to do, I do have a quizzes practice that I would like you to attempt. It is a quizzes practice. This practice does not count against you, so don't worry if you do not do too well. What I have planned, instead of going over all of the questions on the quizzes, I may go over one or two after we are done, depending on how much time we have. But I am planning on putting together a video reviewing said questions so that you can peruse that video on your own time. The reason for this is because I would like to have an in-class, I want to repeat myself, an in-class assessment on Monday on Chapter 5. Just giving you all the heads up on that. Now, how am I going to be doing an in-class assessment on Chapter 5? Well, what I'm going to do is I'm going to make an assignment available to you in Google Classroom on Monday morning. I'm going to make an assignment available to you that is going to be the assessment for Chapter 5, and you will simply, for this particular chapter, be able to type out your answers directly on that Chromebook. So just got to make sure that we are charged and ready to go for Monday. Of course, I will remind you again before we leave here today, but I would like to have that assessment on Chapter 5 on Monday. And of course, for those who are joining us live in the chat, they will be able to get that thing done in the exact same amount of time that you guys will have, and we'll be able to all high-five each other from a distance afterwards. After we are done with going over some of the homework problems, if I have time, I do have something else that I have to do, but I'm going to save that for the end. So, first things first, let me get you logged on to quizzes, and then I want to remind you of a couple things before we get going. Come on, flip over. There we go. Chapow. There's the code for you to join. Now, for those of you, obviously, in the chat, there's a giant glare mark directly on that number. So I'm going to have to write that number up here. It is 581-688. 581-688 for those of you that are joining us in the chat, because there's a giant glare mark directly on the code. I'm going to change the theme over to something that I prefer. I know you guys have seen this synthwave theme. It is much more relaxing than the regular quizzes theme. Also, it has a cool car. A couple of reminders as you are going throughout these problems. These problems are all about the normal distribution. These problems are going to ask you a variety of things. At one point, you may have to utilize your normal CDF function in your calculator. You may have to utilize the normal CDF function in your calculator. Again, second vars will take you to normal CDF. Lower, upper, mu, sigma. You may, at some point or another, may have to utilize your inverse norm function, in which you input an area, the area being the percentile that you are hoping to deal with. Again, percentile, if you're dealing with the 50th percentile, for example, you wouldn't put in a 50, you would actually have to type in 0.50 or 0.5 or whatever. At some point, you may have to utilize the formula for calculating a z-score. And of course, I remind you of that as well. There are various other questions involved in there that seemingly are very logical, and that you would not even have to use any of these particular functions, the normal CDF, the inverse norm, or the z-score formula. I would remind you that at various times it may be helpful to imagine the data drawn in a normal curve. There we go. Just for the sake of argument, somebody do this for me now because I just want to make a point of this. Somebody go to your graphing calculator and hit second vars and go to normal CDF. And when you do that, tell me, what is mu and sigma automatically set to? 0 and 1. Mu and sigma are automatically set to 0 and 1 respectively. And when that happens, when you leave your mu as 0, look what I'm drawing up here, and your sigma as 1, what does your calculator automatically assume your lower and upper limits are? Not the numbers in the calculator, but what do they automatically assume those limits are in the context of the problem? Yeah? Not for that. No, the lower and upper is automatically set, I think, to like some like -1, e, blah, blah, blah. But I don't care about those numbers. I care about what do they mean in the context of the problem. If your mu is 0 and your sigma is 1 going in each direction, then the calculator automatically assumes that your lower and upper limits are z-scores. They automatically assume that your lower and upper limit are z-scores. Do the same thing for inverse norm. Go to inverse norm real quick. Go to inverse norm. Are your mu and sigma automatically 0 and 1 initially? Yes. If you just type in a percentile, then it will spit back at you a z-score. For example, actually do this right now. Inverse norm, it's 0 and 1 for the mu and sigma, leave that be, but instead type in 0.84 for the area, 0.84, and leave it as left. I really don't like changing it off of left, and hit calculate. Do you get a number that is approximately 0.99 something something that you would like to round up to a 1? Yeah. Because the 84th percentile actually equates to a z-score of almost 1, almost exactly 1. That's what that thing is actually saying. It's kind of nice. It's kind of nice. So I want you to be able to knock this out. How many we got here? We got 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, hold on. I got 15 in here. And it says I got 8 in the chat. Are any of you in the chat right now? I got 8 in the chat. People are still joining. Now I got 16. Yeah. Giving people an opportunity to sign in. Again, for those of you, the code, you might not be able to see it because of the glare, but I wrote it up above. Oh, they're all saying yes to me right now. I don't know. That's weird. Cool. Okay. We're going to get started in a moment. I'll be able to knock this thing out. So like I said, you have your notebooks just as a reference, just in case. I want you to be able to knock this thing out. I'm not going to spend the entire class period on it. So at a certain point, I am going to cut you off. But let's see how this goes. Now, if I click start, just so you know, if I click start, if you haven't joined already, if I click start, you still can join. You just have to use the code that is at the top. Oh, here come more people. So anyway, I'm going to click start, and you can enjoy the wonderful music of this new theme that Quizzes has. Oh, they're still joining. Click. Have you guys heard this theme yet? It's so good. Remember, this does not count against you. This is just practice. He's coming for you. I'm saying he's coming for you. Oh, it happened. For you guys that are still working, I want to wrap this up in the next little bit, so I'm going to give you about 3 more minutes for those of you that are still working on this. 3 more minutes to wrap this up, and then I'm going to click end game to see where we're at. Wait, say again? Right. Yeah, right? I know. I like it better than the other one. About 1 more minute. 1 more minute for those of you that are still clicking answers. There are a few. Come on. Come on. Oh, the internet? All right. Click, click. There we go. Now, there are a couple things I want to talk about that a lot of you were able to figure out without me even explaining it. The first thing, I can't remember exactly what the number was, but it was a problem, something like this, where they were like the probability of Z.
Yeah, less than like 2.5 or something.
2.5?
Something like that.
Maybe it was, maybe it wasn't. Doesn't matter. Doesn't matter. This is good to work with. Now, I didn't talk about this on purpose just because I wanted to see what you could do with it. Now, if you notice, it specifically says Z is less than 2.5 for this example, meaning that it is a Z score that they are referring to. And they have P parentheses, which again is not something that I have spent a ton of time on. What is this P actually referring to? It could be referring to a percentage. It is referring to probability, though, which would give you the result in a percentage. But it's the probability of such an event happening, of having a Z-score less than 2.5. Meaning if I drew this normal curve, there's the Z-score of -3. Oh no, it's positive, so I'll go this way. +1, +2, +3. That's a terrible drawing. It'd be having a Z-score of about 2.5 or less. Why am I even drawing it in that direction? Or less. Again, I don't remember what the numbers were. Maybe it was something else. We had a couple like that. So if you were dealing with a problem like that, way to get this thing done correctly, zooming in, would just be utilizing normal CDF, some big negative number, comma 2.5, to kind of get that percentage done. Since it was a z-score, you could leave the mu and sigma as 0 and 1, which would indicate that you're dealing with z-scores. Then you did have a different problem where I believe it was, and I don't remember what the mu and sigma were, but wasn't it like x is greater than 400 or something? Yeah, like x is greater than 400. That's almost exactly the same type of problem where your lower limit would be 400 and your upper limit would be some big number. And then they gave you, and please correct me if I'm wrong, they gave you the mu and sigma in that problem? There we go. So you just have to make sure they're plugged into the appropriate location, and it would spit out whatever answer that is. And we'll talk about that. Yeah. Gotcha. Obviously, my calculator is not the same as your calculator. If I was utilizing your calculator on the Chromebook, mine would look something like this. Zoom in, zoom in. It would look like this initially. Good. And if you notice, the mu and sigma are automatically set to 0 and 1. So I do some low number, 2.5. Paste, and then knock that thing out. And like I said, it doesn't necessarily matter what that giant low number is because that thing does extend all the way to the left. Let's take a look at your problems. Let's see here. There's only a few that are in red. We'll talk about that. Now, obviously, these greens and yellows vary in terms of how many people got them right. As I said, I am putting together a review video. I'm about halfway done with it right now, reviewing every question in this quizzes very succinctly so that you have an opportunity to review them on your own before Monday. Because obviously, I want to have that assessment on Monday. But first, let's talk about 10, 11, 12, whatever those questions were. Let's talk about 10, 11, 12. Now, keep in mind, my 10, 11, 12 are not the same as your 10, 11, 12 only because I shuffled the questions. Keep that in mind. So you're like, I don't remember those. Okay. 10. Excellent. Okay, so yeah, there's the problem. Perfect. And it was a z is greater than 2.46. The normal distribution can act as a probability distribution. It can act as a probability distribution. And the idea being that, well, what are the chances that I pick a subject at random or a number at random from this normal distribution, and it gives me a z-score that is 2.46 or greater. And like I said, in my calculator, it may not be the exact same as yours, but it's the same concept. What was it, 2.46? Comma some big number. And it gives you approximately 0.7%. But again, these answers aren't given it to you as a percentage. They're given it to you as the decimal, which is why the answer had to be that one right there. Nice. Again, one of those things that I didn't talk to you about what that would look like. I wanted to see what you would do with it first, but I didn't talk to you about what that would look like. Let's see what the next one was. Oh, well, would you looky there? Another one of them problems. But again, looks like 6 of you. I mean, did 6 of you get the last one right too? 8 of you got the okay, cool. Of course, guessing and all that other fun stuff. If you didn't know exactly what to do with that one. But normal CDF, some low number, comma, negative 0.39. That's why it spits out that answer of 0.348. Nice. And I sense a theme here. Anyone want to take a guess as to which the next problem is? Oh, would you look at that? Yes. Again, same exact concept. I feel like I misled you, but it was on purpose. So I don't know. Hold on, let me make this large and flip back real quick. Actually, I'm going to do this one on the 84 that I have, just so you can see exactly what the interface would look like. 350, 20, and 400. So the interface would look like this. Normal CDF, 400, big number, 350, and 20. Were those the numbers? There we go. And it spits out a 0.0062 or a 0.62%, which is why that is the answer. Yes?
How do you know like where to put like how would you know if the 400 is the upper or the lower?
Think of it in the sense of what the normal curve would look like. For example, if I were to actually draw out this normal curve with these parameters, the 350 would be right in the middle. This would be 370, this would be 390, this would be 410. And they're saying find the probability of x greater than 400. That's what I'm saying. If you visualize it, it makes a lot more sense. So then it's like maybe right here or higher, which then would give you your lower and upper limit. Yeah. Let me take a look at one of them yellow questions. Because the green ones, I mean, like obviously most of you probably did those fine. But I definitely want to take a look at some of those yellow questions. Okay, 5, 7, 8, 9, hilarious joke. Let's see. Weight of adult male beagles are normally distributed with a mean of 15, standard deviation of 3. A beagle is randomly selected. Find the probability that the beagle's weight is more than 29 pounds. Okay. Looks like half and half on that one. Ooh, interesting. Okay. What was your thought process on this problem? Let me ask specifically of the people who may not have gotten it right. Could you tell me whether or not it was just like, this one looks right? Was it more along those lines, or did you actually try to calculate something? That's a good point. Hold on a second. Let me see. Was it 28? Ah, gotcha. And they wanted 29 or more. Okay. Let's logic this out. Because given that it's multiple choice, you could estimate approximately what the answer would be. Normal distribution, 25 right in the middle. You said this would be 28 because of the standard deviation. 31, 34, 22, 19, 16. And they wanted to know 29 or more. So they really wanted to know approximately here or more. Question, what percent of the data is between those two standard deviations? 68, approximately. It's not exact, but it's approximately. So if I have, or if I'm looking at the middle 68% of data, what percent of the data is on the outside of that? 32. Cut it in half. 16. Which means that moving forward would be approximately 16%. But it would only be 16% if you were going 28 pounds or more. 16%. So since it's less than that, if it's multiple choice, that logic would work. Absolutely, yes. But obviously, if you're going for the exact answer, if this were an open-ended question, I would have to do something along the lines of this. Normal CDF, 29, comma, big number, comma, 20, or you forgot it, 25, comma, 3, which would give you the exact answer. And again, if I did it from 28, you could see it's approximately 16%, according to the empirical rule, but this would be the exact value. Love it. All right, let's go to the hilarious joke. Hopefully you know what I'm referring to. Please tell me that you're not too young for that. Okay, Dylan's nodding yes. Thank you for nodding at my joke. Anyway, Pat and Chris took a spatial abilities test. Pat scored 76. Oh no, you guys did actually pretty decent on this. It got 14 correct, 7 incorrect. And then what percent of individuals would score between Pat and Chris? Yeah, this is a pretty straightforward one, where it's just a matter of Pat and Chris are acting as the lower and the upper limit, and they give you the mean, they give you the standard deviation. So let me actually type this in, and then I'll flip my screen over so you can see it. 80 and 8. So that's what the drawing would look, or I'm sorry, that's what the calculation would look like when you type that thing in. And again, it's like, okay, normal CDF. I'm not drawing that first. I'll draw this first. Normal CDF implying a normal curve, putting the mean right in the middle. It's sometimes good to kind of draw these out to get a good visual with what's going on here. 72, 64, running out of room, 56. And they're saying 76, which is about here, to 94, which is about here. So they're really looking for you to fill in this part of the curve right there. Again, you could probably approximate using the empirical rule, but they don't want an approximation. They want the exact answer. And for this problem, they actually didn't give it to you as a decimal. They gave it to you as a percentage. So sometimes they'll go back and forth on that. All right. One more, and then I'm going to move on from there. Let's talk about this guy jumping, male long jumpers and things of that nature. I actually want to draw this picture out as well. The distance male long jumpers jump for state college jumper are approximately normal with a mean of 263 inches and a standard deviation of 14 inches. Suppose a male long jumper ranked in the 75th percentile. Now, I do want to show you this on your calculators because I want to show you what inverse norm can do. Everyone open up inverse norm on that graphing calculator, just so we can all have an idea as to what's going on here. There's the 75th percentile. Now, there are several ways to get this problem done. Several ways to get this done. First, just confirm for me, your inverse norms are automatically set to left, right? Yeah, that was weird verbiage, I know, left, right? It's set to left, which means in inverse norm, whatever percentage you put in for the area, they're assuming is to the left of that number on the normal curve. So if you put in 0.75, and actually type this in right now just so you can see the difference here, type in 0.75 for the area, type in 263 for the mean, type in 14 for the standard deviation, hit paste and calculate, you should get exactly what, 272.44? Cool. Go back to inverse norm. Go back to inverse norm. Change it from left to right. Change it from left to right. Your calculators have that capability. Mine does not. The one that I have on my phone, the one that I have of the TI-83, it doesn't have the capability of actually changing left, center, right. But if you change it to right, don't change anything else. Don't change anything else. Go down to paste and calculate. Tell me, what number did you get? 253.55? Cool. Now look at this. The mean is 263. Look where the mean is. 253 would be about right here. What does that inverse norm calculation actually do at the moment? What is it doing? How did it get that number? Kind of. I wouldn't say it did the 75th percentile. I would say it found the percentile where 75% of the data would be to the right, which would be what percentile? It would be the 25th percentile. Yeah. So I need you to be careful when you're doing that kind of stuff. There was a problem, I believe, on this quizzes that you had to do something with the top 2%. Several people nodding yes. Let's go find it. I want to go find it. Top 2%. 2%. There it is. Found it. Ah, get out of there. Get out of there. There we go. So you can do this calculation in one of two ways. If you're talking about the top 2%, what percentile is that? It's the 98th percentile. So you could do that calculation with inverse norm where you can type in a 0.98, 100 for the mean, 15 for the sigma. But if you put in 0.98, where would you have to set the left, center, right? For this one, you would set it to the left. Because look what I put in for the area. If I put in 0.98, I'm assuming that 98% of the data is to my left. You would do that to the left. Versus, you could do the exact same calculation with 0.02. You could do the exact same calculation with 0.02, but then you would have to set it to the right. Yeah. Both those calculations would give you the exact same value, which I believe, was it 130.75? Cool. Either way would work. Excellent. Okay. All right. Very briefly, you can close the Chromebooks if you already still have them open. I don't need them right now, but I do need you to write down a couple things before we finish. So I'm going to need those notebooks out and open. Just so you know, that was my supervisor. I'll tell you a story, not about her, just because it's funny. I used to have a supervisor who doesn't work here anymore, and she was from England. She had a very thick British accent. She was adorable. Okay, she was very adorable. And one day, what? Yeah. Do you know her? Yeah. Wasn't she adorable? Just saying. Anyway. So she was observing me in the back of the class, and I misspoke, as I normally do as a math teacher. I misspoke and I messed up a word. And so, the kids kind of called me out of the word. I'm like, yeah, I'm a math teacher. I don't need English. I'm never going to England. And she's sitting in the back of the class, and the whole class is like, oh no, Miss Murphy's going to get fired. And so I did the very natural thing that came to mind. I went up to the first kid in the front row, and I'm like, that was an awesome joke. And I went for a high five. He would not give me a high five. She thought it was hilarious. Just saying. I make more fun of the French than I do the English. All right. I just want to talk about very briefly, and again, I do apologize. I may not have time to go over the homework. I had to skip ahead a little bit because I went over more stuff on that quizzes than I would have liked. So what I may end up doing is I may end up doing a separate video on the homework. We'll see, because I definitely want to make sure that you have correctness to review from. I will definitely, most definitely have a review for that quizzes in preparation for the assessment that I would like to take on Monday.
Okay, so the quizzes and the homework is good preparation.
Yes, absolutely. It's preparation, it's practice, it's getting you in the proper mindset of chapter 5, because this is the last chapter in the first unit in the book. And then, I already had a unit test for graphical displays. So what I'm actually going to do is I'm going to take this chapter 5 and I'm going to combine it as a different unit test with some other chapters that we're going to do within the next few weeks. Yes. Oh, I got plans on plans. Anyway, let's see here. First of all, this is just normal continued. There's no real, fancy name for it other than, it's the normal distribution continued. Still chapter 5. But I wanted to talk about something about rescaling the data. So imagine you have a set of data that creates the following graph. Where it's like, oh, I have a set of data that looks approximately normal. Good for me. It has some kind of average. And it has some kind of sigma, indicating the standard deviation. So just assume it's normally distributed, just for the sake of argument. I just want you to visualize that. Visualize the fact that, oh, maybe I have the set of all adult male heights. And look, there's Derek, right there. Anyway. Oh, Derek. He's coming up for Thanksgiving, but unfortunately I won't be able to see him because of this whole pandemic. I don't know if you heard about this. No? Okay. All right. Now, next, if you add or subtract the same value to each data point, ... I have more stuff to kind of go after this, but I want you to visualize what's happening here. Imagine every adult male in America. You have their height written down on a piece of paper in inches. And then, for some reason, I don't know why, you decide to add like the number 2 to every single data point. Maybe every adult male in America put on shoes that made them 2 inches taller. So you're adding 2 inches to every single adult male in the country. Now this applies for adding or subtracting. If you are doing such a thing, adding or subtracting the same value to every single data point, what is to happen to the mean and standard deviation? What is to happen to the mean and standard deviation? The mean is a certain number. I don't know what this mean would be. Let's just, I don't know. I'm gonna make this number up. I'm completely making this number up. Let's just say that like X bar is like, I don't know, 70. And let's say S is like, I don't know, like 4. Again, completely making that up. X bar will be affected. I was reading the next line of work. X bar will be affected if the average was 70 and then you add 2 inches to every single adult male height. What's going to happen to the average? It's going to go up by 2 inches. But standard deviation will not be affected. It's a very interesting thing. The fact that standard deviation will not be affected when you add or subtract the same value to each data point. It just will not be affected. It won't change. If the standard deviation was 4, it will remain 4 in this context. Because I want you to imagine for a moment, like, okay, imagine my hands are creating the normal curve. This is terrible, I know, but look at this. Imagine my hands are creating the normal curve right there. Now, what is standard deviation? It's a measure of what? Yeah, like this average distance from the mean. It's a measure of what in the word cuss? In the acronym for cuss, C-U-S-S. It was like center, unusual features, shape, and spread. It's a measure of spread. Standard deviation tells you how spread out your data is. Fantastic. It tells you how spread out the data is. So if my data is spread out like this, and then I add 2 inches to every single data point, okay, here's the measure of spread. Now it just shifts over. Same exact standard deviation. Standard deviation doesn't change. It's kind of weird like that, I know. But that's what it does. Furthermore, if you multiply or divide each data point by the same value, ... Now, if I'm multiplying or dividing each data point to the same value, then yes, X bar and standard deviation will be affected. Now, why is this kind of a big deal? Do you guys remember in geometry, again, PTSD, remember in geometry when you did dilations? Same concept, same exact concept. Multiplying and dividing each data point by the same value is very similar to dilations. And if you take like a triangle and you affect a scalar of like multiplying it by 2 or some junk like that, then obviously the lengths and everything's going to like kind of just it's going to be stretched out a little bit. Dilations. Ugh. Was that one of your transformations? I was doing a Zoom call with my niece last night. She lives in Pennsylvania, but she's in geometry honors right now. And she had some questions, and I didn't like how I almost called her professor. I didn't like how her teacher was calling it. So, but anyway. All right, last little tiny bit. Adding or subtracting is, in the statistical world, if you add or subtract the same value to each data point, it is called shifting. It's like you're shifting the data. And if you multiply or divide each data point by the same value, then it's called rescaling. It's like, well, Mr. Ranke, what practical reason would you have for rescaling data? I don't know. Let's say that you were collecting temperature readings and you were collecting them in Fahrenheit. And then, your partner collected them all in Celsius. One of you has to rescale your data. Just a thought. Anyway, like I said, I am going to have a video out for you guys going over this quizzes and probably the homework as well with whatever extra time I have. I don't know, because I'm going to be in like weird PLC groups for the rest of the afternoon. And I don't know, but I'll definitely have that quizzes review out for you. So please make sure that you're checking that out and email me if you have any questions. As I said, assessment on Monday. I timed that out almost good.
That's why it was good. Weekend. I said it as soon as you started.
Yes.
I forgot to turn it in because it didn't occur to me to turn it in because we were coming here.
Could you take a picture of it?
Yeah, can I do it next period?
Absolutely. Yes. Thank you. Thank you, you too. See you guys.
And Emma Pulia.
Thank you, you too. Bye-bye. For like a half a second, I'm like, oh wait, I'm still live right now. I apologize.